So what are catalysts? Catalysts are chemical substances which speeds up a chemical reaction by providing an alternate route of lower activation energy, right?
Yes, sir.
So how does it do so? Mechanism আমাদের দরকার নেই এখন A2 তে mechanism is A2. This is a suppose this is a lake. You're standing on this side and you want to come to this side, right? Okay, you want to come here. So there's nothing. The only way you can cross this lake is by swimming. Okay, so আমরা জানি যে a lot of us cannot swim. So what can be a easier alternative? A boat or a speedboat or even better, boat speedboat হয়তো বা the old people or the elderly cannot move, right? So even better, we put a bridge, right? So what is the bridge acting at? It's making life easier. It's helping us cross it at a with more convenience, right? But once the bridge is built, no matter how many times you move across this bridge, will the bridge change? It wouldn't, right? It will still remain the same. So catalyst basically facilitates a reaction by lowering the activation energy. So এখানে আমাদের এই definition তো obviously তোমরা জানো, এটা types of catalyst. Homogeneous catalyst. So there's a new word which is known as phase. তোমাদের কি আমি phase পড়াইছিলাম?
Sir, gas phase, solid phase.
With states of matter.
States of matter পড়েছি না? হ্যাঁ, তাহলে তো তোমরা পারোই। বলো, what is the difference between a state and a phase?
Phase is like a mixture of the states, like liquid and gas or something like that. And states are either solid, liquid, or gas.
Exactly. Yeah. So any substance can either be solid or liquid or gas. These are states, individual state of individual substances. But if you mix them together and if they can coexist, we call it phase. So homogeneous catalyst is basically the catalyst is in the same phase as the reactants. So for example, iodide ion, which is aqueous, reacts with thiosulfate, which is aqueous, to give us I2, which is a liquid or aqueous, and a liquid electron, plus SO4 2 minus, which is also aqueous. All of them are in the liquid phase, right? And even your catalyst is also in this liquid phase or aqueous phase. So that's why we call this a homogeneous catalyst.
Sir?
Yeah.
Can you repeat that, please?
Your catalyst will be in the same state as others. They will all exist in the same phase. And then we have heterogeneous catalyst. Heterogeneous catalyst. Heterogeneous catalyst is the catalyst is in a different phase as the reactants and products. এখানে reactants and products. So এটার example is Haber process. Haber process nitrogen is a gas, hydrogen is a gas, ammonia is a gas, and iron is a solid. Iron is in solid state. So your catalyst is in a different state than these. So characteristics of a catalyst. It lowers our activation energy. We all know that. It lowers the activation energy by providing an alternate route, right? We all know that. Acha. Next is we just use a very small amount because usually catalysts are expensive. This is one of a very important point, that is catalysts might change in physical appearance, but its chemical properties will never change. Physical properties might change, but chemical properties will never change. So that means they chemically, they remain unchanged. And obviously, a catalyst is never used up. A catalyst is never used up. And catalysts are usually specific to certain reactions.
আচ্ছা স্যার ক্যাটালিস্ট ইউজড আপ কেন হয় না? Why?
ওই যে আমি ফার্স্টে এক্সাম্পল দিলাম, it just facilitates. Right? It just facilitates the reaction. But actively, it has no role to play. এখন তুমি অ্যামোনিয়াতে, what is the role of iron? Because তোমার তো nitrogen and hydrogen is reacting to give you ammonia. What would iron do there? It has no role to play, right?
Yeah. Oh, right.
So that's why.
Makes sense.
So how does a catalyst work? So again, we have this example. We have 1000 molecules. Out of 1000 molecules, 800 of them cannot participate in the reaction because of the activation energy. We have an activation energy of 70. And we have 200 molecules who have an energy greater or equal to activation energy, so they can participate in the reaction. Now, when you add a catalyst, your activation energy decreases. So now, instead of 200, 300 molecules can participate in the reaction, because the ones who did not qualify to participate in the reaction, even they can now participate. Reason? Because now the activation energy is lowered by use of a catalyst. So now even they have energy greater or equal to the activation energy. So now more number of particles have energy greater or equal to the activation energy, more chances of successful collision, greater the rate of reaction. So again, we correlate this with the Maxwell-Boltzmann distribution curve. So what was in the x-axis?
Activation energy.
Molecular energy. What was in y-axis? Number of molecules. This is our activation energy. So these are the molecules who have energy greater or equal to activation energy. So these are the molecules who participate in the reaction. So now, if I lower the activation energy, this is our catalyzed EA. Catalyzed EA. So now even the molecules who previously could not participate, but since we're reducing the activation energy, even they can now participate in the reaction. So what happens? Your total number of molecules participating in the reaction has increases. So since your total number of molecules participate in the reaction increases, more chances of successful collision, greater the rate of reaction.
So আরেকবার বলবেন last partটা.
So this was the orange part, right? The orange part was the activation energy, which the normal activation energy, and the molecules which are beyond this activation energy was participating in the reaction. So suppose the total number of molecules in the orange part is 200. Now you have added a catalyst. What does the catalyst do? It provides an alternate route of lower activation energy. So now this is your new activation energy. So suppose this is 70 kilojoule. This is 50 kilojoule. So you have lowered the activation energy. So even the molecules who were between 50 to 70 have enough energy to participate in the reaction now, right? So how many molecules were present between 50 and 70? 100. So previously there were 200 molecules who were participating or was taking part in the reaction. Now how many molecules are taking part in the reaction?
300.
300. So more particles have energy greater or equal to the activation energy, so more chances of successful collision, so greater the rate of reaction. Okay, so let's first go to the chapter which is there in the book. So this is the graph for the activation energy, Maxwell-Boltzmann distribution. Boltzmann distribution, okay, or it's also known as Maxwell-Boltzmann distribution curve. And then we also studied about the homogeneous and heterogeneous catalyst. And we're just left with enzymes. Enzymes are biological catalyst. How does enzymes work? Basically has an active site. The enzyme has an active site, and to this active site a substrate is basically the substance on which the enzyme will work. The substrate has to have a shape which is like complementary to the active site. So this is the substrate which will have a shape complementary to the active site, and then they're going to form a enzyme
substrate complex.
Enzyme substrate complex. So age they used to think this as a lock and key hypothesis. After lock, if you want to open up a lock, you need the exact key for that lock, right? Without using that a particular key, you cannot open up the lock. But now it's a little different. So A level se তোমাদের যাদের বায়ো আছে, You know that now it's an induced fit hypothesis, right?
Yes, sir.
In chemistry, we will not be needing all these. So যেটা আমাদের দরকার সেটা হলো যে how is enzyme different from a catalyst? Number one, a catalyst is a chemical substance, right? And enzyme is a protein. Okay. Number two is catalyst. The function of a catalyst is not dependent on temperature or pH. But in case of enzyme, it's dependent on it's dependent on temperature and pH. An example, small example. So when you're making a dough, right? It could be for pizza, it could be for a bun, it could be for bread, anything. They don't ask you to give cold water. They also do not ask you to give boiling water. They ask you to give warm water. Why? Because at the enzyme, normally at the enzyme optimum, normally, not all enzymes, but optimum temperature is basically a temperature in which they work best. Optimum temperature is at 37. Optimum temperature is at 37 degrees centigrade. If you have a higher temperature, like at 40 or at 50, what's going to happen? The egg white, when you fry it on a frying pan, what happens? It coagulates, right? The protein loses its functionality. Ekhane same thing. When you have a higher temperature, the shape of the enzyme gets denatured. So your active site does not have a shape which is complementary to that of the substrate. So it loses its functionality. Why? Because when you have very high temperature, ওদের যে bonding আছে, hydrogen bonding, induced dipole-dipole bonds, permanent dipole-dipole bonds, these all break down. So these are the bonds which holds the shape of the active site. So তুমি যখন when you giving them very high temperature, ওদের এই active site এর shape টা নষ্ট হয়ে যায়. Why? Because the bonds which are holding the shape of the protein breaks down. So that's why enzymes does not work under very high temperature or under very low temperature. Next is pH. pH এর same problem. pH আমাদের when we have high pH or when we have very low pH, the enzyme gets denatured because due to acidity or alkalinity, the amino acids, proteins are made up of amino acid. The amino acid chemical characteristics change. How? A2. Okay. So these are the difference between an enzyme and a catalyst. Arekta, most important. Amader Haber process, what catalyst do we use?
Iron.
Iron. এই আয়রনটা কিন্তু তুমি অন্য কোনো রিঅ্যাকশনও ইউজ করতে পারো, ওকে? বাট obviously that would not be as effective, but at least it's gonna work. But enzyme is very, very, very specific. Example is amylase or lipase. Amylase will only work on carbohydrates. Salivary amylase will only work on starch. Pancreatic amylase will work on the broken down polysaccharide chains or polysaccharides. But তুমি যদি salivary amylase কে replace করে, if you put a pancreatic amylase in your mouth, it cannot carry out its function. That's how specific Allah has made enzymes in our body. It's super specific. আচ্ছা, আমাদের বডির সবচেয়ে কমন রিয়াকশন কোনটা? Respiration. Very good. Which is carbon dioxide plus water gives you H2CO3, which breaks down to form H plus and HCO3 minus, right? Carbon dioxide and water is giving us carbonic anhydrase. So, ekhane, instead of carbonic anhydrase, if you give anything else, will it be able to work here?
No.
Never. Never. So, bottom line is enzymes are very, very, very specific. If you add one enzyme to carry out another enzyme, another reaction, it can never do that. Right? So, enzymes are very sensitive. So, this is all about enzymes. Uses of enzymes in the industry. So, আমাদের যে সার্ফ এক্সেল, এরিয়াল, তারপর কি জানি আছে না, জেট. So you know the small granules. The small granules have enzymes. They have enzymes which works on the states. So তুমি যখন একটা ডাল ফেললা, right? The dal, it's a food, right? So they have to work on food particles. So that's why they gave enzymes. So detergent ke tumi jodi gorom panite chubaye rakho, it will lose its functionality. So everything is related to science. So এই জন্য গরম পানিতে ডিটারজেন্ট দিবা না, ওর ফাংশনাল মনে হবে যে না গরম পানিতে দিলে তাড়াতাড়ি কাজ হবে, it doesn't. হ্যাঁ, গরম পানিতে দিলে যেটা হয়, you
dissolves quicker.
You soak it on hot water so that it becomes it becomes a less harder stain আর কি, একটু নরম হয়ে যায়. And then if you add a detergent, it's going to work faster. That's it. আচ্ছা, next, তাহলে আমাদের আর কিছু বাকি আছে? No, we are done.